All right, this goes back to some of the stuff we talked about right at the beginning of the semester. I thought I hadn't started putting up video tutorials. I thought I'd put one up for this. So I'm going to look at sigma bonds and pi bonds, what the two are. Okay, so we have a molecule ethylene here. Ask yourself what the hybridization of the carbon is. Go ahead. Okay? I hope you came back with sp2. So anytime you see a carbon or an oxygen or a nitrogen, any of the second row elements that have that are trigonal planar, that have a pi bond, the way to identify this is the double bond. So any carbon, nitrogen, oxygen that has one double bond will be an sp2 hybrid. I'll do a hybridization tutorial as well. So we're going to look at the bonding between the two carbons. The carbons are single bonded to H's. I'm going to leave those alone for a minute, but let's just take the carbon that we've said is sp2. So a carbon that's sp2, the sp2 orbitals and remember, you now know what this means, the wedge. So the carbon is trigonal planar, correct? So the carbon has an sp2 orbital this way, it has one going back into the plane of the board and one sticking out of the plane of the board. If you turn this exactly side on, this sp2 orbital would eclipse that sp2 orbital. So the red orbitals are sp2. Alright, and then you wind up with a hydrogen out here. At the end of these, the hydrogens can't hybridize, they're simply 1s. They sort of just match up with whatever orbital is present. That leaves you one sp2 orbital, and that's going to be a carbon. Remember, these two carbons are identical, right? Put a plane there, the two sides are symmetric, the molecule is symmetric, there's a plane of symmetry through the board, through the atoms in the board, there's a plane of symmetry right here, so this molecule is achiral. Okay, so if that carbon is the same as that carbon, it will also have an sp2 hybrid, a set of sp2 hybrid orbitals. H is at the end. Okay, so that's the sigma bond. All the bonds shown here in red are sigma. And the definition of a sigma bond is simply a bond that exists directly between two atoms. So if my two hands were the carbon atoms, the pen is the sigma bond. The bond is completely directly between the two atoms. Okay, so I already said hybridization. So what about the pi bond? This is only one bond, two lines there, that means the carbon has two bonds. So the pi bond is made up of two p orbitals that overlap. And a p orbital, and this is simply something you have to have memorized, so the p orbital on carbon has a lobe above the atom, a lobe below the atom, and a node at the atom. The 2p electron will never be found at the nucleus. Okay, makes sense. So you basically need to know what s and p orbitals look like. So both of these, right? If the carbons are sp2 hybridized, a carbon has an s and three 2p orbitals. So an sp2 uses the 2s orbital and two of the 2p orbitals. All right, that leaves a p orbital unaccounted for. It still has to be there, and so then these two can overlap. And again, this is hard to see. It's hard to draw it clear. The pi bond requires the two carbons to come very close together so that these p orbitals can overlap. I use this analogy in class between a handshake and a hug. If I shake your hand, we can stay as far apart as two extended arms. So our torsos could be 3-4 feet apart. If I hug you, we have to get very close. And a pi bond is more like a hug, right? The p orbitals are straight up and down, so that you basically have to lay the bodies close. So the p orbital, again, you need to know what a 2p orbital looks like, lobe above, lobe below, and they can overlap constructively to give you a pi bond. And then, because the lobe is above and the lobe is below, there's no pi bond over here, there's no pi bond behind, If you rotate, if we were to spin around the carbon, so if we were to try to spin around as you've done with single bonds, you would have to break the pi bond. So pi bonds are rigid. You can't freely spin around this carbon-carbon bond. All right.